problem. So blocks and pulleys with friction. So you're going to have a block that slides on an incline and there will be friction. So you're going to look at that. I'm going to do some friction today.
Do you have time for a quick question about that?
Of course.
Maybe I'm having trouble with 1351. It's kind of, maybe you could just give as a hint or it's kind of long.
The one with the spring at the end on the pan. Let's solve it at the end. Let's do friction first.
Yeah.
There won't be any spring tomorrow on the exam.
Well, there's a problem in homework that I'm having problem with friction.
Which one is it?
13, 14.
Okay, we can do 13, 14. I wanted to do another one for friction. This one is fine as well. I just want to emphasize what is important for friction. And if you ever miss a lecture, they are recorded because student is not here. I looked at them yesterday, and I didn't know how good I was at imitating the French accent.
So you're going on the limelight, huh? You're big time enough?
So on YouTube? Yeah, it's on YouTube. I mean, I don't know if you put them all.
I put it on YouTube, so everybody can watch it.
Yeah, okay. So you can ask for the link. It's kind of static and so on, of course, so it's not, it's not a very exciting video. But if you miss something, at least you have a way to catch it. So let's do 13, 14.
Oh, don't worry about that, Charles. Yeah.
Better hope you have fun.
Let's do the first case. Block B has mass M, block A has mass M, and mu is the coefficient of friction for all surfaces. So first we need to talk about friction as a review. If you do a little experiment, for instance, a typical experiment would be you take a block and you pull on the block with a spring so that you can apply visibly a variable force because you're going to see the spring is going to stretch. So there is friction here between the block and the ground. You can.
So folks, I'm just going to give you an update on the Derby race. If you're interested, again, how many of you wanted to do that? The kits are there, and the information that I have is posted on the Engineering 110 website. So you can go to my main website, you can find that on the school, or you could link to that.
We have here Reiner. That's the name you need to look for, but I'll make a link, yes.
But I would capitalize my first name.
It's a capital R.
Oh yeah, that's a capital R. Okay. You can check that out on my course website, and as I get more information, I will post it. And if you have any questions as to specifications, what can you do and what can you not do, send me an email. I may not have the answer, but I can then forward that to the organizers. All right, because I do have some question marks too. So if you don't know what you can sand off or cut off or use, send me an email and I'll post that information on the website. All right. So have fun. The kids are in the lab in the back. I don't know if oh, you have to form groups of 2, so teams of 2, and you get 1 kit. If you need more material, there is more, but you have to go to the lab to get extra wheels or whatever you might need. All right. Okay.
Excellent.
Any questions or?
Can the kids leave campus?
Oh yeah, absolutely. Yeah, you can do the work here or at home, any way you want. Okay. All right.
So I'll think about what kind of extra credit you're gonna get if you do that.
Don't worry, he can edit so that it was always a capital R.
So back to the friction example here. Now what you can do is you can plot so versus well, let's do free body diagram first of the block. What are the forces acting on the block?
Force of tension.
Right, we have the force, let me just call it F. Technically it's not exactly F, it would be the force here, but it's going to be equal to F. What else?
Weight, block.
The weight,
And the normal force.
the normal force,
Friction.
and the force of friction, which opposes the force by the spring. So this is what you can plot. You can plot the magnitude of the force by the spring. Well, first, the magnitude of the force of friction versus the magnitude of the force by the spring. And this is what you get. So if the force by the spring is 0, what will be the force of friction? 0, so you start here. Then it increases linearly. Then something a little bit sudden happens, and itself by a little thing here. And then you have something which is flat. So this is where the motion starts. So this line is at 45 degrees, of course. Here you have static equilibrium of the block. It's not moving. So you pull more and more on the block, and at some point it's going to move. So when it's not moving, the force of friction is equal to the force by the spring, so that you have a net force which is equal to 0. And then it's going to move. So what is interesting is that when it is moving, the force of friction is constant. And just before moving, you have a maximum value here for the force of friction. And what are these values? This force of friction here is called the force of kinetic friction, because it's in motion. And the maximum value here is called the force of static friction at maximum. And this is what you have. You have a relationship between these forces of friction and the normal acting on the block. And that relationship is you have Fk in magnitude is equal to n the normal times a coefficient, which is called the coefficient of, well, kinetic friction. And you have something else, which is The maximum